Okay. Mike's reverence for all things wood was nurtured at an early age by his grandfather, a hobbyist, woodworker, and carpenter. Throughout high school, college, and beyond, Mike explored wood as a building material through woodworking, studying wood products at the Pennsylvania State University, timber framing, carpentry, and designing timber frame structures. Mike lived in New Hampshire from 2006 to 2011. During that period, he was introduced to proper studio furniture and the idea that furniture could be art just as much as painting or drawing or sculpture. This inspiration was a catalyst for the type of finely detailed work he currently produces. After living in Pittsburgh for 11 years, Mike returned to New Hampshire in 2022 and works out of a newly renovated studio on the property where he lives with his wife Jen and Ted, a Newfoundland dog in Orford. In addition to designing and building work on a commission basis, Mike is contributing editor for Fine Woodworking magazine and teaches at the Center for Furniture Craftsmanship in Rockport, Maine. It doesn't say on here, but it needs to be said he is one of our fine New Hampshire Furniture Masters. So Mike, thank you.
Thank you.
And welcome.
Thanks for that introduction, Elliot, and thank you to everyone for being here. It's a privilege to be able to talk to you today about my work. So Elliot covered a lot in his intro there, so that was great. Yes, my wife and I moved away from New Hampshire. So let me back up. I was not born and raised in New Hampshire, and I hope you'll forgive me for that. I grew up in southeastern Pennsylvania, but my wife and I moved here in 2005. We 6 years later we left. We moved to Pittsburgh, Pennsylvania for work. And it took me about 2 weeks to realize that leaving New Hampshire was a mistake, and it took us about 11 years to make it back up here. And so we came back in September or sometime in the fall of 2022. We were fortunate to find a house in Orford, New Hampshire that had a great property, very private, very secluded. Our driveway is a half-mile long. Here is a view of Sunday Mountain from sort of the parking area of our driveway. In the wintertime, we get these amazing sunsets that bathe the surrounding mountains in this beautiful light. So it's a really, both my wife and I really enjoy and love the property. Here we're looking at Mount Cube, which is on the Appalachian Trail. We got a little moon is making a bit of an appearance here. Here's Ted. Elliot mentioned Ted, our Newfoundland. He's a 140-pound male Newfoundland. He's out enjoying the cold weather. Does not like the warm weather at all, and I do not either. And on the property that we bought, there was an existing two-car garage. This is one of the listing pictures. So this is what it looked like when we bought it. And I spent about a year doing a gut renovation to turn it into my studio. And one of the goals, well, the primary goal of my renovation was an aesthetics overhaul, but another goal was to make it a really energy efficient building. Here's a picture of that same building. I took this week. In terms of aesthetics, I was going for more of a contemporary look. I have found that over time my interest has trended toward modern or contemporary. And so this is my first time doing any sort of carpentry work and trying to do contemporary detailing. Another view of the building. So in terms of energy efficiency, it's very highly insulated. My walls are about 10 or 11 inches thick. And it's very, very air sealed very well, so it's super comfortable. It's amazing to me how the interior of my shop will maintain temperature over a period of days or even weeks, versus our house, which is not energy efficiency, is not a tight building, and the interior temperature of the house sort of follows what's going on outside. So the shop is great in terms of energy efficiency. Here's an interior view as we enter through the double doors. The interior, I think, also mirrors that more contemporary aesthetic. Right? There's no trim. There's the interior wall finishes return to the windows. Also very, the color, instead of having wood on the walls or something like that, I went with painted plywood. for a couple of reasons. One is aesthetics. Another is that my eyes are not getting any younger. Some of you may understand that. So I wanted an interior finish that was going to be pretty reflective. I also went with I think I put 9 windows in, and that was to get as much natural light as I could. The floor was concrete, a concrete slab. I put an 1.5-inch thick layer of XPS foam insulation, and then a layer of 3/4 Advantech flooring. And that's all floating, nothing is attached. I did that same detail in my previous shop in Pittsburgh, and lived there for 11 years and never had an issue with it. I like that setup because the floor has a little bit of a give to it, and it's fine in terms of like heavy machinery. You can see this Tanowitz table saw is 1,500 pounds, something like that. The plywood distributes any major loads. There's a larger area to distribute the load, and the foam has a surprising compressive strength, and especially when you have a piece of plywood on top to distribute that load. It's pretty sparse in terms of machinery. I have what I would consider to be sort of the minimum for the kind of work I do. Joiner, planer, bandsaw, 2 table saws, and a drill press. I didn't always have 2 table saws. It just turned out that about a year ago I bought this really sweet 16 or 18-inch Tanowitz table saw, and decided to keep my old Unisaw, and I do not regret that at all. Having 2 table saws, if you have the space, is something that I definitely recommend. So the interior of my space is finished in terms of like finished carpentry, but I would say I still have quite a lot of work to do in terms of like assembly benches, and I need to redo my outfeed island, I call it, where I have the 2 table saws. So the shop is kind of a work in progress, but I really wanted to get in and get working, and I figured it'd be nice to spend time working in the space to sort of figure out all the other things that I wanted to do. Despite all of the lighting that I put in, I have found out that there's a definite need for more task lighting, which I think is probably next on my list. So I'll kind of switch gears here and show some examples of my work. This is a side table I call Figured Out. The primary material is flame birch. There's also some Bolivian rosewood detailing. So the legs on this are tapered and splay outward in 2 directions, and I think that splay and the taper combined give it a really nice stand. It has a little bit of attitude, so it's kind of a fun table. Just a close-up of that material, that birch. I really enjoy just the visual impact that figured woods bring to a piece. I think it's one of the reasons that, one of the reasons that I enjoy working with wood is just because the excitement in a piece of wood is just so nice, so lovely. There's a detail of the cock beating, wrapping the drawer front. So this is a clock. I made this for my wife, and it probably took I don't know. I shouldn't even say how many years it took her at requesting a clock before I finally made this for her. So I call it In Time, sort of a reference to that. So this clock, the only really flat part on this clock is this face. Every other part has some amount of curvature, including the door on the left. It's a coopered door. And then I cut into the coopered door, cut this half circle shape out of the coopered door, and then fit a piece of rosewood in there. You kind of see that bit of rosewood. The door is partially open. And then behind the door on the left is this vertical bank of drawers. Sure, this was a really challenging but fun and sort of a really good learning experience for me. Just every day it was like having to figure out new ways of holding parts to do the operations I needed to do. I show this view. This is the clock laying down, just so you can see that coopered door. I decided, so on the outside of the door I did shape it to a fair curve. On the inside, though, I did leave the facets just so you could sort of see what the method that I used to build the door was. And then one thing that I didn't think about was, okay, that the top would have to sort of jut out to fill that space between the inside of the door and the inside of that flat face. This is a chest of drawers made of curly maple, bubinga, and then there's also a little rosewood bead in between the bubinga base and the curly maple case. And it's hard to tell here. It'll make more sense in the next slide. But each column of drawers is curved to a different radius, and then that curvature is brought into the base as well. So the base kind of curves to this inflection point. I don't know if that's the right term. And then the top also mirrors that curvature. The underbeveled top mirrors that same curvature. So here you can see the different curves. And I find that bubinga and well, at least maple and bubinga, I really like to pair them together. I think they work very well together. Bubinga is just a sexy wood. I don't think there's another way to say it. It polishes really well. It's one of those woods that you almost don't need to finish just because it does polish up so well. But I do love the addition of the little rosewood bead in there. I think it just helps to make the transition from the base up into the case. So this is Livy. This is a previous Newfoundland, but so I built this piece for a charity event in Pittsburgh. It is a teacup-inspired dog bed. So it was auctioned off to raise money for I think it was like a local animal rescue organization. And it was a fun piece, lots of curves, something I enjoy working with, just because I like the challenge of curvature. I like all of the different methods that come into play when you start working with curvature, like steam bending and bent lamination. I think curves make for visually interesting work. I enjoy the challenge of them. So this is a little an ensemble of a mirror and a hanging wall cabinet, and so this is the original piece as I built it originally, and I had this in a gallery in Pittsburgh, and one of the doors it twisted or something in the opening, and I discovered this when I went. We were in the area, my wife and I were in the area, and so we stopped into the gallery just to see what was there. And I discovered this defect, and I was really frustrated and upset with myself. And I took it home that day, and fortunately it was an easy fix. But while I had it, I decided I wanted to change the piece to sort of show that or express that frustration. So I altered the piece with some arrows, and these arrows, I actually made these arrows. I made them from parts, but I made the arrows a long time ago when I was a pretty avid longbow shooter. In hindsight, I feel like maybe the arrows and the arrangement of the arrows in the cabinet was kind of like a bouquet of flowers to sort of apologize for putting the arrowheads into the door. But by doing so, it really made it a visually interesting piece. I really love that pop of color that the red fletching and painted ends of the arrows bring. So this is I made a pair of chairs for a client in New Hampshire, or excuse me, in Pennsylvania, and this is one of those chairs. And this was my first chair, and I found it to be a really fun process. I like working with all of the curved parts in a chair, and I also like that it's sort of it's not like a big chest of drawers where you're going to spend months on it. Chair, there's not that many parts in a chair, and even if there's a ton of like handwork on those parts, still it's not that many parts, and so I found it to be sort of a fast process once I figured the whole process out. And the material, and I forgive me, I have not been talking about materials, but the material here is primarily black walnut. The seat is leather that the client chose. I think the color maybe isn't quite right, but it was not my choice. The back splats of the chair are bent laminations, and the show faces are crotch walnut. And I really enjoy working with crotch walnut. You'll see that later on. I saw my own. I saw it well, I saw it to probably 80 or 90 thousandths, and then sand it down to between 55 and 70 thousandths, something like that. And so, because it is so thick, relatively speaking, compared to like commercial veneer, it doesn't move, it doesn't like bubble, it doesn't distort. So it's really nice to work with. Here's the pair of chairs. Probably the thing I'd point out here is the grain in the back legs. They're not bent laminated, and the grain, it's not perfect, but it does follow the shape of the legs to some extent. And I was fortunate when I went to get material for these chairs, I had a pattern that was sort of a rough pattern because I hadn't completely finalized the shape of the legs yet, but I had a rough pattern that I brought with me to the supplier, and just walking around looking at slabs and comparing my pattern to the movement of the grain of the slabs, I was able to find material that that had sort of the shape that I wanted. Here's a detail of the backsplat and where the back leg meets the top crest rail, and that little rosewood square is purely decorative. There's a slip tenon in there, but no full peg through the tenons. Just a detail of where the side and front rails join the leg. And then this is the table that I made to go along with those chairs. Again, the material is black walnut. The aprons are sort of kind of a veneered assembly of that same crotch walnut that used in the backsplats of the chair. And this walnut has really beautiful figure, a really nice curl. It seems like a lot lately I've been working with walnut, and I bought a bunch of this curly walnut from a place in Pennsylvania called Horizon Wood Products. They're a big company. They export a lot of material, but they also will sell to individuals like myself, and they have an amazing supply. And I think they're one of those places that exports like extremely high quality material overseas, and so they have what I would deem to be extremely high quality materials that are available to someone like me. And I miss that place. They do ship, and I would consider going back, driving down, taking a trailer or something and loading up. Here's a detail of the apron joining the leg. I did this little gunstock miter joint, which I don't know that it's adding much structurally, but it's a nice little visual detail. It also requires a fair amount of work, but it is a nice detail. I'd also point out the shape of the top. So I hand shaped the edges of the top to sort of, it's not an under bevel, but it does give the top an appearance of sort of a thinness to it that I appreciate. So here's a grandfather clock, again curly walnut. We also did curly maple on the interior of the case, because I didn't want there was no lighting on the interior, and we didn't want the interior to be dark. So by using that light material, it's brighter on the inside. So in addition to the walnut and the curly maple, I also have some, I'm not sure, I think it's Indian ebony, and so I use that sparingly because I don't have a ton of it, but here I used it as a little bead in between the, on top of this cove molding that helps make the transition from the case up into the bonnet. The pull for the door on the case is that same material. I used it also down here on where the base transitions up into the case. I got another large cove molding with that little bead detail underneath it. And then I also did an even finer bead around, you can see it here where my arrow is, this fine bead around the panels in the base. So this is a bed. This was the last piece that I made in Pittsburgh. But the material on the bed is curly cherry, as well as there's some dyed oak veneer that you see used at the bottom of the side and foot boards, and also that same oak veneer is on the sides of the legs on the headboard, and it kind of wraps around the headboard. And one of the things, so one technique that I employ to get really nice consistency in this whole piece is that I often will veneer parts with the same veneer that I'm using for, so for example, the headboard is a veneered assembly. But then all of the rails for the base of the bed are solid wood, but on top of them and the proper term should be laminated, because I'm not veneering, there's no cross grain situation. I'm just taking veneer and gluing it to solid cherry. And so because it's solid wood to solid wood, there's no issue with expansion and contraction. But by doing so, I can control what those bed rails look like. So I can say, all right, I want a huge amount of consistency. I want there to be a center line, sort of like there is on the headboard, and then I can mirror my veneer on that foot rail, just like I did on the headboard. And if I cut that veneer from the same material that I'm using, that I've taken, for example, the legs from, then that furthers the consistency in the piece. In terms of, and when I say consistency, I mean just in terms of like the figure. The figure is consistent. The coloring is consistent. Just looking at where the footboard joins the leg, and you can see that dyed oak veneer that I used at the bottom there. And I like that. I like the contrast in color, but there's also a contrast in the open grain oak versus the closed grain cherry. Here we're looking at where a side rail meets the leg of the headboard. Same contrasting materials there. And here's the headboard. You can really see the open grain of the oak. So this is a chest of drawers, and I would say it's probably the favorite, of the pieces that I've built, this is probably my favorite to date. Chest of drawers, the width is a little over 6 feet in total. And when I received this commission, and I kind of saw my job as trying to figure out how to take a pretty common, very rectilinear form and turn it into something that's sort of dazzling. And a couple ways that I did that and hope that I achieved that goal was, well, first of all, the legs. I think the shape of the legs is very nice. It's the legs, they splay outward and they taper from the front apron to the ground. And I think I did a really nice job getting that shape just right. And getting that right is work. It's drawing. It's making mock-up legs and different iterations of those mock-up legs to really nail that down. The top row of drawers, I veneered the drawer fronts in walnut crotch veneer, and I did it in like a mirrored situation that's radiating out from a center point. The bottom 2 rows of drawers, the drawer fronts came from a set of a several board set of walnut, and I book matched them. So you see, you get this repetition of grain pattern repeating from these 2 rows of drawers. You get this figure repeating over on the left hand side, and from a third board in that set, I cut the bottom apron. So again, there's that repetition of patterning that's happening in the apron, as well as those 2 rows of drawers. So on the bottom of that apron, there's this organic shaping done. It's not live edge. I've been asked that several times. It was just an organic shape, and I wanted it to be asymmetrical. Asymmetry is something that I'd like to use in my work pretty often. I find it a little more visually interesting, visually appealing. So here's a view of the side. All 10 drawers were dovetailed by hand, and I have to say that it was a struggle. These figured ends of these 2 drawers, I just remember for whatever reason, the figure when I was cutting cutting the pins on those drawer fronts, the figure was just killing chisels. Where I mean, I could hammer twice, and then I would have to not just resharpen, but usually I would have to regrind and then sharpen because the cutting edges were just getting destroyed. And I was so glad to be done with those dovetails, and I have not done a piece with as many dovetails in it since. Not that I'm avoiding it, but well, I sort of am. But at this point in time, I'm probably over it. But I just remember it being a lot of work and really kind of getting over it. I also want to point out on the side that I kind of kept that same sort of composition from the front. I brought that around onto the sides as well, where I have crotch walnut, mirrored crotch walnut veneer on the top third of the case, and then the bottom is a veneer of solid material. And on the side aprons as well, there's this organic shape shaped into the bottom of the aprons. And since I enjoy, you've probably noticed that I enjoy using beads a lot in my work, I decided to add a bead to the bottom of the apron. So I had to figure out how to make a bead that, I matched that organic shaping of the aprons. And it was just a bent lamination process, pretty straightforward. When I am designing a piece of furniture, I think my primary goal, or the number one priority is aesthetics, and things like joinery and what processes might I need to use, or how am I going to do something. I tend to figure those out after I've designed the piece, just because for me aesthetics is everything. Like that's what drives the design. If it doesn't look good, then I'm not that interested in making it. So I want to make it look good. So after I had this commission and knew what my design was going to be, then I kind of had to switch gears. And when it came time to build, I took a look at the piece and had to figure out what the structure was going to be. And my primary concern on a piece like this, as Claude mentioned, is how am I going to prevent that front bottom apron from sagging under load, right? I've got 10 drawers. They're going to be loaded with clothing, maybe other stuff. I don't know, watches. I don't know, jewelry, whatever. I don't know what all people put in there in a chest of drawers. And I knew that this was designed for a bedroom, so I figured it was going to be clothing, but you never know where this piece is eventually going to end up. So yeah, that front apron, having that front apron sag was a big concern, and that would be unacceptable in terms of aesthetics, but also in terms of function, because the drawer fronts are all fit extremely well to their respective openings. I want very minimal, play, just the right amount of play that I need to allow that drawer to operate smoothly throughout the seasons, and no more. So if that bottom apron were to sag, those drawer openings would change their shapes, and the drawers might rub, they might bind. Worst case, they might not be able to be opened during the highest humidity time of the year. So I came up with a sort of a series of strategies to try to make this case as strong as I could, and I would divide those into two categories. One would be the structure, and that would be like the framing members, where they are, their dimensions, their orientation, and then the other category would be the joinery, what joinery I chose to join those individual members to each other. And I'll start with the structure. So my primary concern in terms of structure was that front bottom apron, because as I said, it's carrying a majority of the load of all 10 of those drawers. So the first thing I did, I shouldn't say first thing I did. I wanted to make that apron as stiff as possible. So one thing that I did is that I made the apron as deep as I dared, or as deep as the design would allow, at mid-span, because that's where the bending stresses are greatest. They're greatest at mid-span. So by making a deeper apron, it's stiffer at midspan and more able to resist loading. That apron, it tapers in height or in depth as it nears the legs, and that's okay because bending stresses, I don't know if they quite go to zero at the legs, but they lessen as you move from the center to the legs. Shear is a concern where the aprons meet the legs, but I felt like the material that I had there and the joinery that I had there was more than sufficient to carry any shear loading, meaning the aprons trying to slip downward. So I made the apron as deep as I could, as deep as the design would allow at midspan, and I also made the apron a composite beam. And by what I mean by that is, so I had the apron, and then there was an interior blade or rail, and so I joined those two pieces together to give it an L-shaped cross section, which makes for a stiffer beam, thus more able to resist the bending stresses that it will see. And so this is and all of these illustrations and a lot of these pictures are from an article that I did in Fine Woodworking about the same topic, the strategies that I use to make a strong case. So we're looking at the end grain of the apron and the end grain of that horizontal rail or blade, depends on what you call it. And I joined those two with a spline. I don't think the spline is doing much in terms of structure, but I like splines because they help me align things during glue-ups. My days of winging glue-ups, which kind of started in high school, and that's not a knock on my high school shop teacher at all, because Mr. Miller was amazing. That's more calling myself kind of a knucklehead back then, where you just put glue on something and throw a bunch of clamps on it, and alignment is something that I'll worry about later. But as I've gotten a little wiser, I do like a little more control over things. So splines are great for alignment during glue up. And I come back to this illustration because now that I've talked about that L-shaped apron, you can see we did this cutaway. You can see exactly how that L-shaped apron works. And I did the same thing on the rear apron. And another aspect of making this L-shaped apron is that these aprons, so they're stronger in resisting vertical loads, but they can also take horizontal loads because they have this composite cross section. And that might not mean anything now, but I'll talk about that a little bit more in a few minutes. And to join the two apron, or the apron and the rail, to make that L-shaped member, pretty simple. Grooves were milled on a table saw. It's just one saw kerf width, so about 1/8 of an inch wide. And I'm working, this is one of those nice operations where I have a common reference surface, so I have the top of the apron and the top of the rail, even though they're in different orientations. I have a common reference surface, so milling that is super simple. There's no change in setup, super simple and accurate. And gluing the two together. Now this photo was taken for the magazine article. So these are dummy parts, that's what I call them, meaning they're not actual parts they're not parts from the actual piece, they're just parts that I made up for the shoot. And I don't use yellow glue. That's where I'm heading with this. I don't like yellow glue. I wouldn't want anyone to leave here today thinking that I enjoy using yellow glue. My preferred glue is polyurethane glue. So the next, again in terms of structure, the next thing I did was to add diagonal braces in the sort of center bays. And if that doesn't make sense, some images a bit later on will help illustrate that. And the goal by adding these diagonal braces would be to pick up load from the front of the case and transfer it back down to the back of the case. And a couple minutes ago I talked about those L-shaped aprons, how they can also resist horizontal loading, and that's where that that comes into play here because these diagonal braces have a vertical and a horizontal component of their load, and so by having aprons that are stiff in the horizontal plane, they can resist the horizontal component of the force coming down through the diagonal braces. And the addition of diagonal braces, it comes from this. It comes from this concept of triangulation, where by putting a diagonal member between horizontal and vertical members, we can make a rigid frame. And Elliot, in his introduction, talked about how I've worked as a timber framer and timber frame designer, and my experiences designing heavy timber and timber frame structures were really great. They helped me get a pretty good understanding of structure and loads, which come into play in a lot of things I do now, furniture, carpentry. So those are really helpful experiences for me. But back to triangulation. These are CAD renderings from a timber frame barn that I designed years ago. I still do a little bit of timber frame design here and there. But in terms of triangulation, so you see a fair amount of triangulation in this barn. You see some triangulation happening here in the roof framing, again up at the peak, also over here in the shed roof. And you'll also notice all these diagonal members, and I would call them knee braces. We would call them knee braces in timber framing. And I tend to put knee braces wherever I can get away with them. And that just sort of depends on what's happening within that building in terms of windows, stairs, interior walls, things like that. So here's the chest of drawers. In this picture, I'm fitting the top drawers, but you can see those diagonal braces, how and you can, I hope you can get a sense of sort of how they're picking up the load from the front of the case and then transferring it down to the back of the case. And those diagonal braces are joined, they're attached into the structure, combination of screws and splines. And the braces themselves are also slightly narrower than the thickness of these front vertical dividers and the drawer guides, just because I didn't want there to be a chance of the drawers ever coming into contact with those braces. So here I am attaching this diagonal brace. I'm screwing through this kicker down into the end grain of the diagonal brace. Where I couldn't use screws because I just didn't have room to get in to pre-drill for screws, I used splines, just teeny tiny little splines, and glue. So here I am, you can see, cutting a little groove in the bottom of this brace, just using a simple tenoning jig on my table saw. Again, I think this was done for the article. They don't like to show dangerous operations in the magazine, so I'm guessing that I would have just set the fence on my table saw and run the drawer guides, run a groove throughout along the length of the top of the drawer guide, and then just sort of held this against the fence. It is kind of a slightly hairy operation because you don't have much bearing surface, but I would have just run this part against the fence, just because that way I'm working off common reference faces, and I know that my spline grooves are in perfect location relative to one another. Still moving along with structure. So I talked about diagonal braces, how I was bringing load down to the back of the case. So I knew that I was going to need a strong back that would be able to take those, not only the horizontal loading like I talked about, but also that additional vertical loading. So I made the back a series of composite beams. So what I mean by a series of composite beams is I have a bunch of horizontal rails or blades, and then I have these backboards. And so to every blade, to every intermediate blade, middle blade, I glued the backboard above it and the backboard below it were glued to that blade. So on the bottom, so I have two intermediate aprons that had that situation, and then at the top back rail and the bottom back rail, I had one backboard that was glued into each of those rails. So in essence, I had a series of four composite beams, composite meaning they're made up of multiple members with different cross sections. Here's that rear bottom L-shaped apron rail assembly thing, and then this backboard is glued to that assembly. Then moving up, I have this intermediate rail or blade, and the backboard above it and the backboard below it are attached to that rail. Same thing with this next intermediate rail, and then on my top rail, I have one backboard that is attached to it. And these backboards are also screwed into the vertical dividers, or vertical dividers, I think that's probably the best term, at the back of the case. So I have this extremely rigid case in the back that is, and all of these deep beams attached to the vertical dividers make for an extremely rigid back. When I say that I attached those backboards to their respective rails, I did just some stub tenons, and those were glued. And so here I am just milling tenons. I guess you would call that a bare-faced tenon, so super easy to mill, where I'm just running the part against the fence on the table saw. So I get consistency working off of a reference surface. And then here I am milling corresponding groove in one of the, I guess this would be the back rail, the back L-shaped apron rail assembly, milling a corresponding groove in there. Assembly, again that yellow glue, still not a fan, because of the water in it. Because I work hard to get nice, well-fitting joints, and then the second you add yellow glue, everything swells up, and now that joint doesn't quite fit as well. I also think when I'm edge gluing boards, that water changes things, and so So when I edge glue boards, I take the time, so I'll joint those edges, and then I'll shoot them with a hand plane, and I will take the time to sort of fit the boards to each other. So kind of if there's a slight distortion in one edge, I try to avoid that, but I'll kind of mirror it in the mate. And then I have found that as soon as I add that yellow glue and things expand, and they kind of expand differentially because there's more water at the surface versus down lower, that I have found that I don't like the qualities of the water in the glue and what it does to my joinery, and I switched over to polyurethane. It's not water-based. It is actually a lubricant when you're trying to assemble things, as opposed to yellow glue, which is like some new unknown state of matter that's like a lubricant for 5 seconds, and then it wants to start to grab very quickly. And I know yellow, that's not to say you can't use yellow glue in woodworking. You certainly can. It's been around forever. Just I've found that I much more appreciate polyurethane glue. Any other polyurethane users here? No. Okay. I would probably not 12 hours. So clamp time is 1 to 2, and that can sort of depend on ambient conditions, because it does like some moisture. It's a moisture cured glue. So if I'm working with polyurethane glue in the summertime, I don't worry about needing to add any moisture back in. If it is the winter time, when everything is nice and dry, I might take just a shop rag, like a box of rags from Home Depot, but a shop rag, and put some water on it, and then sort of dab along. So you might say, well, you just said you don't like the water in yellow glue, so why would you add water back to your polyurethane glue? But the thing is, it's so much less water, and I'm controlling, I'm just putting a little bit of water on there. But clamp time is 1 to 2 hours versus, you could probably take clamps off after a half an hour, 20 minutes, half an hour with yellow glue. But let's say we're talking about gluing 2 boards together to make a wider board for a top or something. Even if I glue those together with yellow glue, I don't want to start working that for 24 hours or so, because I want to let all that water to evaporate out. Otherwise, I could end up with sunken joints, a sunken glue joint. So with the polyurethane glue, I would clamp for 1 to 2 hours, and then in that same example of a top for something, and then I could probably start to work it right away, but I probably still let it go a full 24 to get a full cure. But in terms of the added clamp time with polyurethane, I just kind of build that into my schedule, right? Maybe I'll put things in. If I have a bunch of things to clamp, I'll start one, and maybe by the time I get through everything else and get back to that, enough time has elapsed that I can take clamps off, or I'll glue things up and then take lunch and come back and sharpen or something like that before taking clamps off. So squeeze out. So it comes down to metering, right? I'm not over applying the glue. Any glue is going to make a mess if you over apply it. I mean, especially like think about epoxy, trying to deal with hardened epoxy if you've got a ton of squeeze out. But squeeze out with polyurethane, I just try to avoid it. So there are places where I shouldn't say I try to avoid it. I try to control where it happens. There are places where, like show faces, it would take me probably a couple minutes to think about like a situation to describe this, but there are places where you can put polyurethane glue and know that if it does squeeze out, it doesn't matter because it's going to be on the back of something. The cleanup is pretty easy. It's like a hardened foam after it cures. So cleanup is easy, meaning it's not hard like epoxy that you can just sort of cut it away with chisels or a utility knife or even a scraper, card scraper. But I think the best advice I would give is just sort of prevention of any type of squeeze out. We left off, we were gluing a backboard to the bottom apron rail assembly. And so the backboards are not joined to one another, but they are splined to one another just to keep them in the same plane so they don't sort of bow out relative to one another. And I did that with just another spline. And this is probably just a floating spline. It's not really doing anything in terms of structure. It's more for alignment. And that was just, again, a simple process of milling grooves in all the backboards where on the edges where they'll meet. And by doing that composite beam that I talked about, where two backboards met each other, they were intentionally gapped, and that's for seasonal expansion and contraction. And so this spline is shaped to also allow for that seasonal expansion contraction, meaning it's not, the boards as they expand are not going to hit on that spline first. So another structural aspect of the piece is the case top. So the top was, I think I was only able to get maybe 7/8 or 13/16 thickness out of 4/4 boards after they were, milled, glued up, and then remilled again. And I wanted a slightly thicker top. So I took offcuts from the milling process, and also when I buy material, I always, for a specific project, I always buy more than I need just so that I give myself options should I need them. But to thicken the top, I just glued on offcuts to the underside, and they're all added such that the grain direction is parallel so there is no issue with cross grain expansion contraction. It's essentially as if I took a thick top and then milled out recesses in a couple of recesses in the center of them. But a thicker top is going to be more resistant to deflection. So that's one of the reasons that I took the time to add on that extra material. But I also wanted a thicker top visually. And so the top, you can see in this image, the top of the case, to the top of the case, I hard fastened this top blade to the top of the case, meaning it's screwed. There's no glue in there, just in case that top ever needed to come off. But it's screwed with a fair number of screws through that top rail up into the top of the case itself, thereby making yet another composite beam that's now probably closer to 1 3/4 inches thick. And I'm also controlling the expansion and contraction of the top by doing so. So I've hard fixed it at the front, meaning I'm going to maintain that slight overhang at the front that matches the sides, and then any expansion and contraction that happens is going to happen toward the rear of the case. So back to this image. So I put the top on, clamped it in place, and then marked all my screw hole locations. And you can see there's a fair number of screws. And then I don't like to try to pre-drill and install screws for the first time when the top is on the case, because it's too hard for me to get in there. Feel like I'm crawling into the piece and there's not a lot of room, so I'll mark locations of screws, take the top off, flip it over. You have to be, well, in any case, you have to be careful that you're not drilling holes or driving screws through the top. If you've ever done that, you flip something over, and it's one of the most disappointing feelings you can have in furniture making. And another thing I'll do is I'll pre-cut the threads in the screw holes when it's inverted on the bench top, just because it makes it a lot easier to drive those screws back in when I'm assembling for the final assembly. I'm not in there contorted trying to put enough force to cut threads. So the last item I want to talk about in terms of structure are the case sides. The case sides may appear to be a frame and panel, but and I guess in a sense they are, but they're veneered panels, so they are attached to the legs. So it's an extremely rigid frame because I have this large panel, again, glued to the legs. I'm not relying on joinery by having like a top and bottom rail. And my concern here is I don't want this case piece to rack, because you can imagine being fully loaded with clothing and somebody saying, oh, I want to push it closer to the wall or pull it away from the wall. And depending on how much weight there was in it and how it was moved, I mean, you push something like that, there is a potential that you would really stress joinery if I just had, like I said, top and bottom rails or something and mortise and tenon joinery. So here's a sort of an exploded view of the panel in the center is, again, it's a Baltic birch veneer with Baltic birch plywood with veneer adhered to both the inside and the outside. And in terms of having the two different veneers, so the crotch walnut and the regular sort of plain sawn walnut, they're just two different veneers adhered to the same panel. And then you can see this light band in the middle. That was just a dado that I milled to fit in this horizontal piece that mimics the rail or the blade on the front of the case. So you can see there's the bottom apron is joined to the legs with slip tenons, and then the center panel is joined to the legs with splines and as well as glue. So this might be a good example to talk about squeeze out. Whoever had the question about squeeze out. So when I assembled the panel to the legs, I probably pre-glued the splines in, and so any squeeze out that happened in that process I could clean up before I did a full assembly. But then when I assemble the leg to the panel, I can put more glue on the inside of the spline where squeeze out that happened is going to happen to the inside of the case where I don't care, and I put no glue or very little glue on the front edge of the spline, so that when I assemble, I'm not scraping off all that glue and creating glue that's going to squeeze out toward the front. And I also would have put glue on the edges of the panel itself. So where the edges of the panel meet the leg, that's a glue surface, so I want to put glue there. So same thing there, I would probably only put glue on the inside where the panel meets the leg toward the inside. And if I do it on the outside, it's just a little, very little, because that is not where I want squeeze out. I don't want to have to be, that panel is inset relative to the legs, and I really don't want to have to be trying to work in there cleaning any kind of squeeze out. So we talked about structure. Then another set of strategies that I used was to make this case as strong as I could is the joinery. First thing I'll talk about is a double dovetail joint where the top rails meet the legs. So it's this kind of joint. So those top rails, they're maybe 5/8 of an inch thick as viewed from the front, but in plan view they're much wider than that. So essentially they're members that are sort of laying down horizontally. So they're wide enough that I can dovetail them into the leg, as well as there was a sort of a top cap on the side panel assemblies. And I really like this joint because it intuitively, it's a mechanically strong joint, right? Without, as long as those dovetails fit well into the mating members, that is a joint that resists withdrawal. So that means that it's also going to help the case resist racking along its width. So here we're looking at where the back top rail meets the leg and side assembly, and you can see the double dovetail. You can see that there is a nail in there. I don't think the nail is necessary from a structure standpoint, but I just use it as a clamp. So I put glue into the sockets, put the double into both dovetail sockets, set that back rail in place, and then just drove a nail again as a clamp, so I didn't have to try to clamp it because I would have used polyurethane glue, and because of the expanding nature of that glue, I do always tend to clamp things. You can also see the slotted holes at the back of the case here. So remember, we're at the back of the case, and these slotted holes allow for expansion, contraction of the top, because again, I hard fixed the top to the front of the case where I don't want any expansion, contraction happening there, because I want a really tight joint to make another composite beam. Cutting the double dovetails is pretty simple. I definitely recommend notching the bottom so that I have essentially I'm creating a shoulder that defines the width of the case, and it's nice to do that because I can then set the double dovetail in place. If I need to, I can put a clamp or more likely a ratchet strap in this situation to sort of clamp that top apron in place by its shoulder to do my layout, the transferring of my layout. So cutting the dovetails, just a bandsaw operation. I don't even know if I cleaned them up after bandsawing. I cleaned up the shoulders, but I was talking about cleaning up the cheeks of those dovetail-shaped tenons. I'm not sure if I cleaned them up. But here I am just chopping out the waist, and then some glue and driving that nail home. And again, this image is a total fake. The glue that you see, this joint had already been assembled. The glue is just there for photography for the article. I would have used polyurethane glue here. So as soon as we took the photo, I wiped that glue off. But don't tell anyone. It's all smoke and mirrors. All right. Next joint I want to talk about is where the intermediate rails or blades meet the legs. So again, this is the joint where those horizontal blades that they're running horizontally, but they're also laying down horizontally where they meet the legs. So it's a double tenon, and these blades are wider than the legs, which you can see in this illustration, which means that the blades can wrap around the inside of the leg, which is kind of nice because it's just add additional glue surface area. So I've got the double tenons, and they're nice because there's more glue surface area. They're going to resist that blade twisting. That blade might want to twist. That joinery arrangement will help to resist that twisting. And so to make these, I'm not somebody who tends to look at something and say, boy, I'd really like to cut a ton of tenons by hand and cut a bunch of mortises by hand. I would much rather figure out a process to do most of that work with a machine-based method. If I have to do final fitting with hand tools, perfect. But I really, the idea of again cutting a bunch of things by hand is not that appealing to me. So when it came time to cut this joinery, I wanted to avoid a ton of handwork. So the mortises were done just with a hollow chisel mortiser. That was a pretty simple setup. Everything registering off the fence and shifting the fence to cutting one row of mortises on all the legs, and then shifting the fence to do the second row. But then when it came time to mill the tenons on the ends of the aprons, I started to think about a different way to do it. I tend to shy away from integral tenons on things because for me the process of setting up and cutting integral tenons is just not intuitive. meaning for me, it just doesn't make sense the way it's typically done. So I said, well, what if I came up with like a pattern, and then I was able to pattern route these double tenons on all of the parts? Because I did have, there were 4 intermediate blades, so there were 8 of these joints. So that would be 16 of these tenons. I'd never seen this before and decided to try it. So what I did is I made a sandwich. I made up a sandwich of parts with different thicknesses that became my pattern. And so in this image, you can see I've got 2 strips of material here. It's just some poplar. And those 2 strips are, each strip is inserted into a mortise. So I took the time to fit each of those to a mortise, and then here I'm working on the strip that is going to fit in between those 2. And here I am checking the fit of that 3rd part that's going to fit in between those 2 pieces that represent the mortises. Here I am fitting a 4th piece that represents the space between one of the tenon cheeks or one of the mortise walls and the back of the leg. And I don't show the fitting of any more strips, but I end up with this sandwich that has all these different strips which represent different parts of the geometry of that joint. So this thin strip up front represents the distance that represents the front of the apron to the first tenon cheek, and then I've got all these other strips that I talked about already. So I glued those up together, cleaned that off with just to level everything out and get rid of any squeeze out. And then I had this pattern that I fit into each, that I checked the fit on each joint to make sure it fit those joints. It was a really nice fit. It took a little time to sort of figure out the process and come up with this, but I think it worked quite well in this application, especially since I had, if I were to try to cut these tenons via a traditional route where maybe I'm using a tenoning jig, there would have been so many different setups to create all of these, to create all of the shoulder cuts, because essentially, really, I have 1, 2, 3, 4, 5 shoulder cuts happening in here because that apron wraps around the inside of the leg. And then I added a fence so that I'm registering off the front edge of everything, and it was just a process of using a pattern routing bit to cut the tenons, checking the fit. And again, here you can see how that apron wrapping around the leg provides yet another glue surface area to make this joint as strong as I can. Here we have all 4 of those parts, one end of all 4 of those parts. Last joinery consideration that I'll talk about is where the bottom aprons join the legs. I much prefer working with slip tenons as opposed to integral tenons, and that was my approach here. Oftentimes, if the geometry allows, I'll oftentimes miter the ends of the slip tenons where they meet inside the legs. That lets me get yet another. It's another glue surface area. It's another way that I'm really making a strong joint, because I miter those slip tenons, and then I make sure that when I'm inserting them, that they're actually making contact with each other. So, and when my editor was in the shop with me, and we were doing the photo shoot, at the end when I had an extra leg and I had some slip tenons, and I put one slip tenon in with no glue, and then I applied a little bit of glue to the end grain of that mitered slip tenon, and then inserted an adjacent slip tenon. So all I'm doing there's no glue on the mortise walls or anything like that. All I did was sort of see how strong this joint would be by gluing the end grain of those 2 splines together inside the leg. And I couldn't pull it out. I clamped the leg in my vise after the glue had cured and tried to sort of torque it out, and I couldn't get either of the tenons out. So I think just by mitering and gluing them together, I am adding a fair amount of strength to the joint. So that, for me, that process is, milling mortises in both the leg and the aprons. I do that with a plunge router, and here, next picture is a little better, but I have essentially a big block of oak So big block of oak, and the top of the oak, the top of this block of oak and this side are perfectly 90 degrees to each other. And then on the back side of this block of oak, there's a cleat that captures the fence on my router edge guide. So I have a fence on the edge guide. When I set the router down on top of the block of oak, the cleat or the fence of the router engages with the cleat on the back, and so it can't move laterally. It can slide along the length of that block of oak, but it can't move laterally, unless I, loosen things up and allow the router itself to move on those bars that are part of the base. So I'll route the mortises in both parts, and then I make slip tenons. So I just take long stock, mill it to size. Here I am cutting a miter, and then here's the process of gluing them in place. And because I do want intimate contact of those two slip tenons with each other on the inside of the leg, I tend to glue them into the leg ahead of time. Because if I let's say I glued one apron into the leg, the squeeze out that occurs in the bottom of that mortise would make it very difficult for me to get intimate contact when I put the adjacent slip tenon into that joint. So I'll glue them both in at the same time. I can, there's a little bit of play in the length of the mortise, so I can sort of fit the parts in and kind of wiggle them back and forth till I can feel that they're making intimate contact. And here I'm finally using polyurethane glue. And again, because the glue does expand as it cures, so I'm a belts and suspenders person, so I'm just putting some clamps on here. I don't think that the polyurethane glue would be strong enough to squeeze those slip tenons out of the joint, because they should be pretty well fit. But again, it takes 2 seconds to put a clamp on, and again, I'm kind of a belts and suspenders person. So those are the strategies that I employ to make a strong case piece able to withstand its loads. Hope you guys found that informative, and thanks again for having me.